Hello, everyone. Hello, and welcome to today's Azure Administrator Live Study session. So, thanks very much for joining us today. We really appreciate you taking the time to join us today. So, today we have a special guest that will be speaking on networking, part of the networking objectives of the Azure Administrator Certification exam. So, but before we get into that, if you're yet to join the Meetup group, please go ahead and use the URL on the screen to join it. So that's very important because that's how you get notified of future events that we're going to be setting up. We're about rounding up the Azure Administrator Life Study series. We have other series like DevOps Fundamentals and AI series going on. So if you want to be notified when those events are happening, make sure you join the Meetup group. We also have YouTube channel for the Nigeria community group. If you're yet to subscribe to the YouTube channel, please use the you're probably watching us on YouTube now, so please make sure you click the subscribed button to do so. So that being said, some other information that we want to share around the different events that we have that are coming up. So right now we're currently on network traffic management, and we have a special man called Sir Kofi that will be delivering that today. However, we also have a session later today on DevOps Fundamental, and we have Imo Etuk that'll be walking us through Docker Kubernetes with Azure DevOps. And of course, next week we'll be bringing all of this to a close next week. So please ensure that you follow the rest of the session. Okay, so let's see what we have today. So are you ready, ladies and gentlemen, for the special review? We have the special man himself. We have Sakofi himself. Hello, Sakofi. How are you doing?
I'm doing very well. I hope you're doing well as well,
Yeah.
Sir David.
Yeah, doing well. Thanks very much, and thanks very much for really doing this. So
Oh, it's my pleasure.
presenting the session. Yeah, so we're really looking forward to it. You're an expert in the area of networking. You've been doing this for a very long time, since the days of Cisco CCNA version one, probably.
Yeah.
so so we're really looking forward to it. So what I'll do is I'll just go ahead and hand over to you, Sir Kofi, and then if you do have any questions, please feel free to leave the question in the chat window, and we're going to read that out to Sir Kofi as we go on. But over to you, sir. So please feel
All right,
free.
thank you. Thank you, Sir David. It's just a wonderful, lovely weather out here today. I hope you're enjoying it. And wherever you are, I hope you're enjoying the weather out there. It's a pleasure for me to take over this session today. If you've joined us for, let's say, for the past 2 weeks, we actually look into Azure networking, and then the following week we went to the site-to-site connectivity. And for this one, the end of the network series, this will be the network traffic management. So I hope you're excited as I am. So let's think about it this way. When we say a network traffic manager, you notice that this is something that exists on-prem, and shifting to your service to the cloud as well, you're still going to face the same workload, and you have to find a way to balance your traffic across multiple endpoint, multiple service. And Azure have you covered. That's where you have the network management. So I'm just going to quickly, as you can see my screen. Can you see my screen, by the way? I'm just going to, let me,
Yes, it's clear. So yeah, we can see your
it's
screen,
clear.
sir.
All right,
Yes.
that's great. Let me see if I can put this into presenter mode. All right, so let me get this way. One moment. Okay, so with a network traffic management, in Azure, there are 4 services that actually deals with this. So when we talk about load balancing, right, it refers to the distribution of workload across multiple compute resources, which is aimed to optimize resource, maximize throughput, minimize response time, and even avoid overloading a single resource. And that's exactly what all these 4 services actually do. All of them have certain traits that make them useful in certain scenarios. And as you already know, with Azure, one of the key elements is cost. So even though there will be certain services that probably have all the bells and whistles that you might need, it might not be suitable for certain scenarios. So you have 4 services, and then you can choose depending on what scenario you want to work with, essentially. So let's go to the next slide. All right. So when we talk about these traffic load balancers, the one I've just showed you, let me just go up again. So we have the load balancer, the application gateway, traffic manager, and the front door. Today's session, we're going to focus on these the first three, right? But when you're selecting these services, one of the key elements will be this, whether it's global or regional or HTTP or HTTPS. So those are, oh, sorry, it should be HTTP or non-HTTP. So those are the main key elements that you can look into when you want to select any of those services. So bear in mind, the last one is supposed to be HTTP versus non-HTTP, essentially. So when we talk about the global load balancing service. So essentially, if you want to distribute traffic across regional endpoints, cloud or hybrid on-prem services, these service routes end user traffic to the closest available backend. They also act to change in service reliability or performance. So when you have a specific service and you want to ensure that that service um, is distributed across different, let's say, different resource regions on Azure, right? There are certain there are certain load balancing services that will cater for those type of scenarios, and then other ones is regional, right? There are certain scenarios whereby you just want to send traffic to one specific region, but you want to load balance those traffic, and then you can use those type of service as well. And then when we talk about the HTTP and the HTTP non-HTTP, some of these services are layer 7 based and others are layer 4. So when it's layer 7, then obviously it will be the HTTP and HTTPS, it will fall into that category. But there are certain scenarios whereby you want to use the layer 4, for example, the load balancer. In that case, it will be the non-HTTP traffic. And then you have to use that for that type of non-web load balancing. Now, let's talk about load balancer. All right. So that's the first of the service we're going to talk about today. When we talk about load balancer, as you can see the definition there, it distributes inbound requests to a pool of systems. It could be a VM, it could be virtual machine skill set, or probably will be app services. This will allow you to balance the traffic across those resources, right? So I got a picture here. So this is a request coming in, right? So let me just bring up my pen. So this will be your endpoint, right? And your endpoint will send a request through. Once you send a request through, it will hit the load balancer, and then the load balancer job is to distribute the traffic seamlessly to the resource behind it. And it all have to do with how you've actually set this up, right? It can be multiple resources here, multiple, and we'll have to distribute the traffic either across all of them so that it balances the traffic across everything. All right. All right. So now let's look at the load balancer work process. All right. When setting up a load balancer on Azure, right, you first of all have to set up a front end. The front end could be either a public address or a private. So depending on whether the load balancer you're trying to set up is internally you want to balance your traffic, then you have to use a private IP address for that. If you want the traffic that comes in coming from outside your network, then you can use a public IP address. Then once the traffic hit the public IP address, it will then distribute the traffic across to the resource behind the load balancer. And with the load balancer, it operates at layer 4 of the OSI model. Right. And you can also set up a DNAT. So essentially, you can set up a DNAT, which will allow you to access certain end backend resource essentially. And also, when we talk about the SKU for this service, there are two. There's a basic and standard. And one of the key things is that wherever the basic is still in the standard. So the basic is the minimum sort of SKU you can actually select. And there's a lack of features. It doesn't have everything. For example, it doesn't have AZ availability zone. And I believe in terms of um, the in terms of the percentage for availability, I don't think there is any sort of like a numbers to that. Let me bring this up. I'm just going to see if I can share this screen here. All right, so I have the SKUs here. Let me just clear my screen. All right, so in terms of the SKU, right, as you can see from here, for the standard, it supports up to about 1,000 instances of instances, and also for the basic, it only have about 300. And in terms of looking at the help probe, this can support HTTPS as well for the standard, but for the basic, it just TCP and HTTP. And there are other things that are quite essential. For example, you might want a high availability port. The basic doesn't have that. And the last thing I was talking about was the SLA, which have about 99.99%, but for the basic, it doesn't have it. So when you are selecting the SKUs, it's quite essential that you consider all these factors. And when you select a standard SKU, you need to ensure that the public IP address you select also fall in the same SKU as well. It has to be standard. If you don't, then it won't work. That's actually it's defined here, as you can see here. You have to match. If it doesn't match, then you have issues along the line. All right, let's go back to our presentation. Yep. So the other thing is that you have the health probe as well. So you can set up a health probe to constantly check to see whether your endpoints actually up and running and there's no issues. If there is issue, then it will stop sending traffic to those resources. And what will happen is that it will continuously monitor that. Once that service or once that endpoint comes back up, then it will start to dish out traffic to that resource again. All right, so like I mentioned earlier, right, we do have a private IP address and also a public IP address when you're setting up the load balancer. And this tied into what we call the external and internal load balancers. When you set up the external, more likely you want traffic originating from outside your network to come in, and then the traffic is distributed to your servers behind it, right? So this will fall into the criteria of external. We'll call it fall into the criteria of external. And then for the internal bit, there'll be scenarios whereby you just want your internal resources to be load balanced. So that you don't want the traffic to be leaving your network. So in that case, you can use this to cater for those type of scenarios as well. All right, so demo time. All right, so I'm just going to bring up my Azure portal, and what we're going to do is, right, we're going to run through the setup of a load balancer. So as always, once you come to Azure, all you have to do is search for the specific resource you want. So this will be a load balancer. So once you type in load, we should see the load balancer showing up here. And then to create one is quite straightforward. All you need to do is just click on the create button here, or you can click on the create load balancer here as well. So I'm just going to click on this plus icon here. Okay, just gonna move here. Right, so just like every service that you want to create on Azure, you first of all have to select your subscription, and you have to define your resource group or select a resource group that is already defined. I think for this, I have a resource group already defined as Demo Lab 1. All right, then you have to give it a name. So I'm just going to give this name as Load Balancer 1. And then you select the region um, you want this one to the resource to be deployed in. I will select East US. And then this is what we were talking about earlier. You have the option to select either internal or public, depending on how you want this load balance to behave. So for this scenario or for this demo, I'll use the public. And with the SKU, you select what sort of SKU to use. You can select the standard to get all the bells and whistles, or you can select the basic, which is a stripped down version of the SKU. So I'll select the basic for this scenario. And as you can see right there, Microsoft recommendation is to select the standard SKU for load balance, especially for production workload. But this is just a test environment, so I'll select just the basic. All right. So the next part is the IP address. All right, you have to define a public IP address. So what we're going to do is we're just going to name this one as load balance I public IP. I'll just add one to it. I'm not sure whether I have one more. Right. So by giving it a name, it will create the IP address automatically. And for the IP address assignment, I'll leave this one a dynamic, but most often, since this is an external resource, more likely you want to use a static, and then you can tie the static IP address to a domain name, essentially, so that your people trying to access a resource can actually access the connect to it with ease. But this one is just a demo, so I'll stick with the dynamic. And you can also utilize the IPv6 address as well. So that's about it. So once you define all these, all you have to do is you can add a tag as well if you want to, but I will go ahead and just review and create. Okay, validation passed successfully. So once validation pass, you simply have to create the resource. So this is the first part of it, to create the load balancer. Once you create the load balancer, then you can then configure it. So you have to understand that when you create this, there's more to do. It's not just about just creating this and then you're all good to go. And one of the fundamental things is this: with what we are creating now, we want to obviously associate this to, let's say, service on our network. So essentially, you need to ensure that you have those resources already prepared. So if you don't have them, then obviously you have to deploy those as well. So I have VM skill set deployed on this environment. So we can use that one for this specific demo. So let's go to the resource since it's created now. Okay, so once let me just refresh the page a bit. Okay, right. So as you can see from here, it will tell you the resource group is falling to, and then it's showing the public IP address. And we have not added the backend pool yet or the load balancing rule yet. So, and also the help probe. So all of these are blank. You can't see anything. And if you click on the front IP configuration, this is where you configure your IP address, the front end. That means the IP address the client will hit. I've already defined this whilst we were creating this load balancer service. So that's why we have this service here. But you can easily add another one if you want to. So the next part will be the backend pool. Right. The backend pool will be the resource you want your end users to gain access to. So the traffic will hit a load balancer, and then the load balancer will then forward the traffic to the backend pool. So we're going to create a backend pool now. So creating is just super simple as well. All you need to do is just click on the add button here. and then you give the backend pool a name. So I'll name it BE for backend, and I'll add pool 1. And then you have to select where your resource is located for the specific network. So for this demo, I'll select demo lab 1, and then you have to select where you want to associate them to. You can select virtual machine or virtual machine skill set. So I'll select virtual machine, and then you see the IPv6 or IPv4, depending on what you have deployed on your environment, and then you select them accordingly. All right, let me just quickly. Okay, I have a skill set. So one moment, let me just select the skill set. All right, so once you select skill set, that's what I have in my environment. So it will then allow me to select that specific skill set. And then you can select this one here. And then click on add. Okay, so go and issue the deployment. Let me see, say here, this one. All right, let me quickly redo this. Let's go back to the load balancer. And I'll make it backend pool 1. Just this one here. And let me see VMs. Okay, I don't have any VM. Okay, I think it might be the SKU because I might have a different SKU for the skill set. Let me have a quick look. 1 second.
It's a very interesting one.
Yeah,
So yeah, if on the notification, I saw like so it showed something like a conflict when you clicked on it, sir.
let's go back
So
to
the
that.
notification in the top right corner, the notification of the error message, when the not yeah. So there, if you click on the deployment field, and I think that it came up with something like a conflict somewhere. Yeah, so conflict. If you click on operation details, what's it conflicting with? Let's see that. It says operation details there. Yeah, that one, sir. So let's see if we scroll down and let's see at least one deployment operation. If we scroll down forward, yeah, yeah, at least one deploy. Yeah. So where it says message. So what's that? What does that message say in full? If we scroll it forward a little bit. So yeah. So let's scroll it slowly because yeah. So if we scroll it back and let's read it slowly and see
So the
what that
VM
message says.
said cannot use a basis queue. Yes.
Yeah. So you're right, sir. So essentially, you want a load balancer that is standard skill.
Yeah. So
Yeah.
let me quickly deploy this load balancer again as a standard queue, and I think we should be good to go. I'm just going to create a brand new one. LB. Okay, I'll leave it as standard, and then yeah, I'll leave it there. And for this, I'll just name it load balancer public IP. And for the availability zone, I'll set this one to none. So just no zone. And I think the rest, yeah, I think will be good to go. Okay, so sorry about that, guys. Yeah, I should have been more mindful of what I created earlier. All right, so hopefully this should be extremely quick. So while this is deploying, let me go back to a PowerShell. So the next thing will be the um, application gateway. So
Yes,
application
Sir Coffee,
gateway.
apologies
Yeah,
to interrupt. So there's a question in the chat window.
okay.
If you can take that, yeah. So
Yeah,
from
sure.
Okoyemi, so Okoyemi is asking a question. It says, are we going to deploy virtual machine skill set before doing the load balance? I guess the question is about, do we have to have the endpoint resource before we
Yeah.
create the load balancer, or can we create it either way?
You can create either way because the whole point is that, like I mentioned earlier, it's all about you can create the load balancer object, but to associate the backend pool, that's when you need your VM. That's when you need your virtual machine skill set. So whether you create the load balancer first or afterwards, the key element is that you need the backend endpoints. So that means wherever it is, you have to create it at some point. Yeah,
Yeah. Thanks very much. So I'll go back to
welcome.
this. Yeah.
All right, no worries. All right, I think this probably is done now. So let's go back to it. Okay, deployment is still in progress. So yeah, here we go. So let's quickly go to the resource and I'll run through this extremely quickly. Right, so the backend pool, let's select the backend pool. And then as we were doing before, you click on add and then you define the backend pool name. I'll just keep it simple. Like I'll make it backend pool and then you select your VM. And then now I have the option to select the NIC and also the IP addresses. That's what I was expecting before. So then I'll select the IP addresses. And then from here, I should now be able to select my resources. So I'll select, um, I have three machines in the VMSS, right? So I can select all of them. So I can select that, and then I'll select the last one as well. All right, so here we go. So now by clicking add, we will create the backend pool, essentially. It's simple and straightforward as it is. So I know we're running through an issue before. That's all part of the whole show. Sometimes these things happens, and then it will help you to understand that the elements that are essential, like the SKU. So, like I was saying before, these SKUs are quite essential. You need to be mindful of it each time you're creating these type of environment. So now the backend pool is all created. We have our resources there. Then next thing is that we create our health probe, right? So the health probe is also extremely straightforward. It's simple by just clicking on the add and then give it a name. So like always, each service might have a specific name. You can give it to it, and then you can select the protocol. So this give you the option to select um, TCP, HTTP, and HTTPS. The reason why I have the HTTPS here is because I'm now using the standard SKU. If it was just the basic, then I'll have the two options, the TCP and the HTTP. Now the port, you can define a port you want to use for the probe. I'll leave it at port 80, and then the intervals will be how often it will attempt to check to see whether the resource is up and running and it's good to go. Then you can then define at which threshold is of these sort of requests or these sort of like checks am I going to say, okay, there's an issue with this service. So you define that here. So I'll leave as the default as 2, and then simply click on add. Okay, no issues there. Thank heavens. Right, so the next thing is that you need to combine everything together. All what we created were individual elements that we can combine under what we call the load balancing rule. So once you've defined all these 3 elements, then we can combine them here. So you click on the load balancing rule, and then you click on add. And then you can give that a name. So I'll just make it simple, load balancing rule 1 or something like that. And then this one is IPv6, so you leave it as it is. Then you select the front end or front end element that we created. So we select that one. The protocol, we leave a TCP, and a port. We're using WebSoul port 80 and the backend port. So the main elements here are the ports and also the backend port. It's very important that you keep note of this, because sometimes the traffic will come in from your externally on port 80, but then the backend port are listed on a different port. Then you can use this option to now define the port these real servers are listening in on, and then you put it there. So the next part is that you have to select the pool we created, and then the health probe that we also created. You select that here. And for the session persistence, sometimes you want certain resources to continuously access one of the backend pool. And I think most banks actually prefer this option. They don't want you to be switching to any other service. And sometimes when you do switch, it will break the connection. So if, depending on the service or the resource you're trying to get your end users to access, then you have to select it accordingly. Okay, then the timeout, we leave it as it is. The timeout, we leave it there. The floating IP, therefore, there are certain services that require floating IP address. A typical example would be SQL. So we're not using any of that. So we'll move on and then click on add. So now this will add everything and tie all what we've created together. The load balancer, our servers that we have deployed, it will tie everything together. And then we have a way to monitor to see whether specific services are not running well. And then it will have the ability to have that continuous flow so that there will be no downtime, essentially. So the service has been created successfully. Now, if you go to the overview, we should see the public IP address we can use. All right, so one moment. Here you go. So this is the public IP address here. But before I go ahead and test this, I need to ensure that my virtual machine skill set is updated to pick up the backend pool. So I'll quickly go into that one, and then I will click on instances, select all the instances, and update them together. So once I select all of them, I will upgrade it. Okay, while this is taking place, I'm just going to check to see whether I can access the resource anyway. There you go. So as you can see there, once it connects to that one, let me refresh again. All right, now let's use a different there you go. So you see there, that's a different server to the other one. Okay, so that's the end of this load balancer. Let's quickly move on to the application gateway.
Yep. Another question came in for you, sir.
Sure.
Shall I go ahead with that? Yes, sir.
Yeah, go ahead. Yeah.
Okay. So the other question that just came in is from Okwayemi. So it says, which of the protocol is the best for the ELF probe?
The health probe. For me personally, I'll prefer to use a service port, because more likely those end devices, for example, what we are demoing now, the specific service was on port 80. So if I constantly check that same port, if anything is happening to that specific port, then it will be easily identified. But if I'm using a different probe, like checking a different port altogether, then it might not be helpful. So I'll always encourage that you use the same service port you're using for your resource as the health check, essentially.
Okay. And also, what about like in case of like the HTTP or the TCP? Is there like benefits to using one over the other, or any preference there?
Um, for me, I don't have any preference per se, but if I'm to choose, then probably I'll go with the HTTP, or probably or the HTTPS, one of those two. Yeah,
Okay. Okay. Thanks very much, sir.
welcome. Right. So now let's move on to let's go back to here we go. All right, yeah. Right. So application gateway. So this is the other service that you can actually use in terms of load balancing your traffic, but this also gives you much more. Essentially, this one will operate at layer 7 of the OSI model. The first one we look at will operate at layer 4. But the benefit of operating at layer 7 is that it gives you the ability to look at the specific request, the specific path is taking. So that means you can then do more. So for example, there's an option whereby you can use URL path. So the beauty of this one is that some website they will reserve specific endpoints, specific servers for, let's say, for their videos. They optimize that server to ensure that any request that come to that specific server is optimized for video, so it'll perform in a better way. And also, it helps them to also cater for their resources. So layer 7 will help you to do just that. All right. Now let's move on to the next one. So some of the features of the application gateway is multi-hosting. You can have the ability to have multiple, let's say, URLs point you to the same server pool or server farms, right? But all don't have a specific domain name. And also the ability to redirect. So for example, let's say you decommission a specific server, you can easily use the option of redirecting your traffic to another server or another farm of service. And also you have the URL based routing, like I defined earlier, right? The other option is that you give the ability to have the SSL/TLS termination. Most firewall applications have this service, and you have this one on the web application load balancer as well. And I think that is another very, very important element of the application gateway is the ability to have the WAF, right? So you have the web application protection, which will allow you to protect your backend service against well-known exploit like buff overflow or cross-site scripting or SQL injection. So it's very, really, very good. The first one we look at do not have that. The load balancer doesn't have that extra functionality. And there's also session affinity, whereby it can constantly send traffic to a specific resources or within that specific session. Right. And there's an AKS, the Azure Kubernetes ingress control as well. Right, so this is straightforward. So let's jump onto demo. Hopefully this won't take that long. Right, so let's jump back to our Azure environment. Let me close this one down. Okay, so for this, like we demo in the first one, all you need to do is search for that specific resources. So this one is application gateway. So just type in the search field and select application gateway, and then simply click on create. And then, as always, you either select or define your resource group. So for this one too, I have created demo 2. So I'll select that one. And then you define the application gateway name. So I'll name this one as app gateway 1, something like that. Right. And I'll put this one to the East US. And for the enable auto scaling, I'll leave it at once yes. And for instance, 0 to 10, that's good. And for the availability zone, you have the option to select different zones as well if you choose, but I'll leave that one as it is, none. And for the configuration, this is also very essential because one of the things you might come across is that when you are selecting your network, it requires specific network name. So as you can see here, when I already have a subnet 0, but It doesn't like that. You want me to say you must only have application gateway. So you want me to define something along that line. So what I'll do is I'll click on manage subnet configuration and then create a new subnet. I'll name this one as gateway subnet, something like that. And I think address is good to go. I'll leave the address as it is. So you define address for me based on what I already have. So I'll leave it as it is, and then I'll simply save this. Okay, that's lovely. It's all done. So let's go back to our creation wizard. So I'll click on this. Let me see. Click on that one. Yep. So going back, now I have the ability to select the new subnet I created for the app gateway, and it loves this one. No issues with that one. All right, so the next part is the front end. So essentially, unlike the load balancer, right, the application gateway, whilst you're creating your resource, it allows you to actually configure it. So the downside of this one is that it might take a longer time for the whole thing to establish. So with the load balancer, it didn't take that long. So that's one of the things you have.
Oh, I'm not sure what happened there. I think Sarkoph's system froze. So apologies for that. So hopefully everything comes back. So let's see. Uh, yeah, maybe some network connections going on over there. So by the way, really thanks, really appreciate ladies and gentlemen joining us. Really appreciate you taking the time to follow this live study series. So I can see that that's disconnected completely. So I hope that Kofi will be able to reconnect. So, but in the meantime, if anyone has any questions on what Kofi has been talking about, please feel free to put that in the chat window. And again, we'll pass it on to him. So hopefully you'll be able to reconnect again very soon. But okay, in the meantime, let's go get some questions. Let me see if I can get some questions for you. Okay. I'll put some question in the chat window and we'll see how much we're understanding what Sarkofi has been teaching us since morning. So let's see. Let's see. Let's see some questions for you in the chat window. So I will call Sarkofi and see how he's doing. But in the meantime, let's get some questions going, ladies and gentlemen. So here is a question for you in the chat window. Let's go with this. Okay, let's go load balancer. Okay, let's put this here. So you have two VM instances in different availability zones in Azure. You need to ensure that the failure of one zone does not lead to service downtime. Which load balancer option can you use? So let's say basic load balancer, standard load balancer, front door, or traffic manager. Okay, so let's see how we do with that question. So I'll put that question up in the chat window. essentially select whichever one you think applies. So I'll put that up on the screen also. So you have two virtual machine instances in different availability zones in Azure. You need to ensure that the failure of one zone does not lead to service downtime. Which load balancer option can you use? So we'll have four options there. So which one do you think? So while you're doing that, I'll see if I can reach Sir Coffee on phone. Just put your answer in the chat window and let's see who gets that correctly. Oh, what do you think? So I can see Apoyemi saying front door. Any other answers out there? Let's see. Any other answers? Trying to get a hold of Sir Coffee also while we're waiting for that. So let's see. Any other answer from anyone? So which load balancer option do you have? So I'll go ahead and give the answer in a few seconds if no one else is responding to that. Yeah, I can see Vijay says standard. I can see Aquarius says standard. Yeah. So I think I'll agree with you. So standard can see Skywalker. Mr. Skywalker himself said standard. So and I think I'll agree with you for standard load balancer. What about traffic manager and front door though? Can we not use them? Can we or can we not use traffic manager or front door to achieve that scenario? Would that work? Will it not work? What do you think? So okay, anybody taking that question? So what about front door and traffic manager? Can I use them to achieve what the question is asking? Can I use Azure front door or Azure traffic manager to achieve that where my service does not have downtime in case a zone goes down? So by the way, I've been able to make contact with Sarkofi. So unfortunately, the internet connection in this place went down. So it's using another option to try to reconnect. So hopefully we'll be able to have Sarkofi himself back on. But I'm waiting for answers. I'm waiting for what people think. We'll be able to use front door or traffic manager to do the same thing. Let's see. Oh, no one's taking that question. So the answer to that is yes, we can use both traffic manager and front door to achieve the same thing. It's going to be a much longer configuration, or it's a different configuration that we can put in place, but we can still use both of those to achieve the same thing. So yeah, we can definitely, yeah, we can use front door, we can use traffic manager also for the same thing. So that's a that's a nice one. Let's see. Any other question? Let's see. Any other question that I can ask? Let's see. Okay, so here's a question for you. Here's another question. What is the IP this in relation to Azure Load Balancer? Okay, so this one is a bit of a more detailed one. You need to really understand load balancer for you to be able to answer this question correctly. Do not Google the answer. So that won't be allowed. That's cheating. So do not Google the answer. So this IP address that we have on the screen, what is this IP address in relation to Azure Load Balancer? What is the significance of this IP address in relation to the Azure Load Balancer? Again, do not Google the answer. That would be considered cheating. And we're going to seize your examination paper if we catch you cheating. So, so let's see. So Sakofi is trying to reconnect using his mobile phone, Tetrin, and see if that works. So we're going to see if that works. So this IP address has a significance to Azure Load Balancer. What is the significance of this IP address? Anyone can get that correctly without looking up Google. So let's see. Let's see who is going to get that correctly. Come on, ladies and gentlemen. Come on. Give it a go. Even if you want to guess, what do you think it is? Even if you guess, what would you guess that IP address? What's the significance of that IP address to Azure Load Balancer? Okay, going. No one taking that. Okay, I can see Akwayami as an answer. Let me bring that up on the screen. It's like a standard IP used by Azure. I'm not sure. I'm not sure, but I think you explained it before. Yeah, it's used by Azure. It's used by load balancer also in relation to something. So I can see Moyoshore said, let's see, that should be the public IP address of the load balancer. Oh, is he the public IP address of the load balancer? Okay. Okay, let me go ahead and just bring up the answer. Let's bring up the answer so you see what the answer is about. So let's see. Let's go ahead and go screen share. And let's go to screen number 2 and share that. Is that IP address? So let's see. Oh, so hopefully you can see my screen now. Hopefully it's all clear. So let's see. Any other answer? So let's see. I think somebody has another answer. Address of the resource to be consumed. No. So this is the virtual IP address for the old stack, that's Azure Infrastructure Load Balancer, where the Azure ELD probe originate from. In other words, this is the IP address that Azure Load Balancer uses to do ELD probing. So be aware of that. So if you have a load balancer in Azure and your load balancer in Azure has an internal or external IP address, maybe it's using a public IP or an internal IP address, whenever it's sending the ELF probe to your backend instances that you have in Azure, those ELF probe would be originating from this IP address. Because I've had a few people contact me in the past to go, that IP address keeps showing up on my backend instances. Am I being hacked? Is somebody hacking my network? So nobody's hacking your network. That's the IP address that you're going to see. So when you go to do like a packet capture on your backend instances and you check the IP address source of the ELD probe is going to be coming from that IP address. So there you go. So let's see. Let's do a few more questions because we're waiting for Sir Kofi to rejoin. And again, sadly, internet connection went down. So hopefully things will be brought back again. So let's see. So, few more questions for us. Let's see, a few more questions. Um, okay, here's a question for you. Rosemary said, "Awesome, yeah." So sometimes it's good to sort of like, oh, okay, yay, we have Sarkofi coming back. Yay! Hello, Sarkofi, how you doing? Can you hear me? Can you hear me, Sarkofi? No, I think it's still connecting. So let me put him back offline. Still wait for him to connect. Okay, I have another question for you. Okay, here's a question for you. Can we use combine VNet peering and um, basic load balancer? So here's a question for you. Next question. Can we combine VNet peering and basic load balancer? In other words, if I have a basic load balancer in a virtual network and the resource that I want to send traffic to is in another virtual network and I pair those virtual networks together, can I send traffic to that resource in that other virtual network? So to make my life easier. So instead of me having to go put another load balancer in that network, just use a single load balancer and send traffic to different resources in different VNet. Can we combine VNet peering and basic load balancer? Okay, I can see lots of people going no. Mr. Skywalker himself said no. Okoyemi said no. Any other answers? And you will both be correct, Okoyemi and Mr. Skywalker. So 15 points for you both for getting that correctly. So yeah, so you're right. We cannot combine that. It has to be standard. So awesome. But we have the man, the myth, the legend himself is back with us. So he just had to quickly go do some superhero stuff. So he's back now. Sakofi, can you hear me? Oh, we can't hear you. Maybe your mic is muted somewhere, but I think that you may be able to hear me. Hello, Zakofi. Can you hear me
Hello,
now?
can
Hello,
you hear me
hi.
now?
Yeah, I can hear you now. Yeah.
Oh, I do apologize. I'm not sure what happened to my internet connection. It just decided to just drop off. So I was working on a laptop. Now I have to switch to the desktop, which seems to be much stable. So yeah.
Yeah.
So I don't
So I'm
know if
thinking,
we have
yeah,
to continue
yeah.
or continue later.
I'm
What's
thinking
the
we can just give a summary of the point and then we can
yeah
then call it a day. Yeah.
yeah
Yeah.
sure
So I'll just
okay.
let you carry on. Yeah. And by the way, if you have any question, any other questions for Sakofi himself, he's around. So all the difficult questions that you were piling up, make sure you ask him before he goes. Okay, Sakofi, over to you. Sorry to conclude.
Okay, that's great. So, like I said, I do apologize for what happened. I mean, I was actually in the middle of demoing the Azure application gateway, and it actually went offline. So, essentially, what I was going to show you was to use the virtual machine skill set to for the demo, essentially, to allow traffic to come in, and then show you what's going on. The next thing that I wanted to talk about was the traffic manager as well. So in terms of the traffic manager, the beauty of that one is that is allow you to have resources in different regions. That's one of the beauty aspect of it. It's a DNS based sort of traffic load balancer, and it have about six sort of rule base you can actually use. And these six rule base, we have the performance, we have the subnet, we have the geographic, we have the I'm just trying to remember them on top of my head. Right. So we have the priority as well. So one of the main ones that a lot of people use is the performance. The performance, it allow you to have the ability to send traffic to
the closest sort of like a region that is close to the customer. So if the resource or if the request from the customer is coming from North America, what will happen is that once the traffic hit the traffic manager, it will distribute that one to the region that is close to the customer. And the other aspect will be the priority. The priority rule set, it also gives you the option whereby you have a specific or dedicated server or region that you want all the traffic to flow to. And if, let's say, anything happened to that specific server or specific region, what will happen is that you will have a fallback service as well, and then a fallback to the other service in the other regions as well. And the other one I forgot about was the wait. There's an option whereby you can use a wait system. Then you have multiple service across different regions, and then you give them different weights. And then what will happen is that the ones with a higher weight or will take the priority. It will all traffic will flow through that one. So, for example, if you have a weight system whereby you have three regions and you've deployed resources in these three regions, and then you want region one to have the higher weight of, let's say, of 100, and the rest are, let's say, 2020. That means majority of the traffic will flow through the region with a higher weight. So that's how it works. And other ones that many customers will more likely use will be the geographic one. And the geographic one also give you the option whereby, let's say, I mean, in this current modern times, most companies will ensure that certain data stays in specific region, right? So if, let's say, it's a global company and they have customers in North America, customers in Europe or Africa, Asia, one of the things they probably will do is that they will ensure that, let's say, traffic or resources in North America, right? If a customer wants to access any of their data and they're in North America, they can only send the traffic to North America. This helps them in terms of protecting them again from, let's say, the GPDR, for example. They don't want to violate any of these countries, set laws or European laws or whatever. So they will put those measures in place. Right. So it's quite unfortunate that I couldn't demo that for you, because I had that one prepared as well, that was going to show you how these sort of traffic manager also how to set them up. But yeah, unfortunately, due to certain issues I had with my computer. So yeah, that's about it. So, Sir David.
Yeah, man, that was awesome. That was absolutely awesome.
Yeah,
Every
I
time you
sincerely apologize.
no, no,
Yeah,
that's like normal. Like internet, sometimes it misbehaves and
yeah.
stuff like that. But I tell you something. I was making notes as you were speaking. I always learn something every time you talk about networking all the time. So really appreciate you taking the time to do this. And ladies and gentlemen, thanks very much for joining us again. So we'll call it a close today. We do
Yeah.
have a session on DevOps Fundamental later today. I've put Sarkophis Twitter account in the chat window, so please do follow him. Make sure you bombard him with all kinds of
Yeah,
questions on Azure networking, and I'm sure he'll be happy to help you. So regarding
definitely.
the recording will be live on YouTube immediately afterwards. So for Sarkophis, I'll just end with two things, and then we'll stop. So number one, where can we order your type of posh dress? We really need that type of shirt. Number two
Oh, you mean?
is we need your posh shirt. We really need to get that type of, it's proper, colorful, nice shirt. I love to get that. Number two is somebody asked a question and I would like to know your thoughts on that. So Dali asked a question and says, I would like to become an Azure guru. So any advice that you want to give to him before we end this
Well,
call now?
it's all about practice, 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 and also, constantly practice and engaging in the community like you're engaging now helps you to grow a lot. Because that's what I did. Sir David has been a very, very, he's an instrumental to my progress in Azure. Because constantly we talk about Azure, we do a lot of learning in regards to Azure. So that's how you develop in anything. And repetition. The more you do the thing over and over again, you become a master of it. Yeah.
Yeah. Thanks very much. That's very, very useful. I can see somebody saying Twitter is banned now. So, because I said follows our coffee on Twitter. Okay. Okay, no problems, ladies and
All right,
gentlemen.
thank you
See you
guys.
later today. So 6 to 7 DevOps Fundamental. Have a nice
All
day.
right.
Bye for now.
Bye.